So you guys have done reflections and rotations and translations before, and in this activity we're going to be talking about what happens when you put those together and make sequences of transformations, sometimes called composite transformations. First, let's talk a little bit about how transformations are related to congruent figures. So we could say that two figures are congruent if they have the same shape and the same size. Another way to talk about congruence is to say that you could obtain one figure from the other through a sequence of rigid motions. For example, take this triangle up here. If I can use a series of rigid transformations to map it onto this one up here, then they're congruent. So for example, in this case, I could probably reflect that and then translate it upwards to get my new triangle, right? So I could use a reflection followed by a translation to map my first triangle onto the second. That means that's another way of demonstrating that those are congruent triangles. So rigid motions, what does that include? Well, we've discussed two of them a little bit: reflections, translations, and rotations. Non-rigid motions include dilations. That's where we allow the size to change. So the first three, these rigid motions here, will result in congruent figures. Once you dilate it, however, you're changing the size, and so it's no longer going to result in congruent figures. So let's look at an example down here. Can you use rigid motions to map triangle BUG onto triangle ANT? Sure we could. We could do that with translations. We just move it 6 to the right, so that would be x plus 6, and we move it 6 down, so that would be y minus 6. And that's how we would say it in words. So I just demonstrated how to do a basic translation right there, and just for review, here are your basic rules for different types of transformations. We have translations where we add a and b to x and y, or subtract a or b from x and y. We have reflections, so we could reflect our triangle over the x-axis like that, or you could reflect over the y-axis like that. We could also even reflect over the line y equals x, or even over the line y equals negative x, like that. And for rotations, we could rotate 90 degrees counterclockwise, 180 degrees, which is the same counterclockwise or clockwise, or 270 degrees counterclockwise. Now once we get back to 360 degrees, we're exactly where we started. So let's try out a few basic transformations here. Our first step should be to graph our pre-image, and then we're going to follow the directions. In this case, it tells us to reflect over the x-axis. So here's x, so that means I'm going to reflect this way. I notice that point B is 1 point below the axis, so I'm going to put point B prime 1 point above the axis. Right now, A is 5 below, so my new A is going to be 5 above. Right now, C is 5 below, so my new C, my C prime, is going to be 5 above. Then all I need to do is connect the points of my image. So how do my coordinates changed? Well, for point A, my x coordinate stayed the same, and I now have the opposite of my y coordinate. And that's true for point B, and also for point C. So my x coordinate did not change, so I'm just going to write x for my rule. And I have the opposite of my y coordinate, so I'm going to write negative y. And remember that negative, it doesn't mean negative necessarily, it just means opposite. I have the opposite of what I originally started with. So this is my rule. And that was in our table too, wasn't it? Then when we reflect over the x-axis, we have the opposite y value, but the x stays the same. Why don't you try the next one, reflecting over y equals x? So for this next one, I first plotted my triangle CAT, and then I drew line y equals x. To find my new points, I figured out that A was half and 1 diagonal away from y equals x. So half a diagonal and a whole diagonal away. So let me go half a diagonal and a whole diagonal over here, and boom, it should be right there. And then I see that C is just half of a diagonal above that red line right there, right? So I want to go half a diagonal below it. So here's my new A, and here's my new C. See, it's just all about using that line as your line of symmetry, and then going that distance to the other side. And you can see that my triangles overlap each other. My blue triangle and my black triangle overlap. And actually, T prime didn't change locations at all, did it? It's in the exact same location as T. So what changed here? Well, my X's and my Y's switched places. My X became my Y and my Y became my X for all of these. It's even true for T, even though the location didn't change, that rule would still apply there. It would still work. So my rule for this transformation then is going to be Y, X, since my Y's and X's just switched places. This is just kind of a review, so why don't you try the rotations on your own? Hit play when you're ready to see the answer. So here for this first one, we rotated 90 degrees clockwise, so the same direction as the clock. This is the same thing as rotating 270 degrees counterclockwise. And in this case, what happened is my X's and my Y's switched positions. The sign of my X changed, became the opposite, and the sign of my Y stayed the same. So looking at the top of my coordinates here, for point C, -5, my Y value became my new X, and that -1 X value was changed to the opposite, to a +1, and it became my new Y. And that's the pattern that happened for each of those points. And here's what happens when you rotate triangle CAT 180 degrees. We just have -X, -Y for our rule. And I just want to point out that when you're only doing one transformation, you can just follow the rules if you want to and graph the new coordinates following those rules like we have in our table. But you don't have to. You can just do the rotation or do the reflection on your coordinate grid and then figure out how the coordinates are changing. You can figure out the rule by yourself. Do what's easiest for you. So now we want to talk about sequences of transformations. What happens when you apply more than one transformation to the same pre-image? So in this case, we're given a pre-image, triangle ABC, and we're given a rule, y minus 3x plus 2. So we want to use this algebraic rule to find the new coordinates of our image. So first, I see that my new x coordinate is going to equal my old y coordinate minus 3. So let me write down my old y coordinates. They were 2, 2, and 3. Now I need to subtract 3 from each of them. So here's where I got that 2, 2, 3 highlighted in red. And this subtraction, this minus 3, is why I'm subtracting 3 from each of those values. For the y coordinates of my image, I'm going to take my original x coordinates and add 2 to each of these. So here's my original x coordinates highlighted in blue, and this right here is why I'm adding 2 to each. So here are my new coordinates after applying that rule. Let's use these to plot the image. So now we have our image and our pre-image. Let's talk about what transformations were used to map our pre-image onto our image. One way to map the pre-image onto the image would be to reflect the pre-image over the line y equals x, and then to translate it 3 left and 2 up. You could probably think of other ways to map that pre-image onto the image as well. Whatever works is a valid answer. This is just the way that I came up with. And indeed, this sequence of transformations does match that rule right there. So here's another example, and this one's actually a little bit easier, maybe a lot easier. It tells us what's going on. So here's our pre-image. We're told to reflect it across the y-axis, so this way. So here's x prime, y prime, z prime. And you can see why the rule down here makes sense. We have the opposite of our original x coordinates, and our y coordinates did not change. Next, we want to translate 1 left and 3 down. And here's what that looks like. This is our final image, x double prime, y double prime, z double prime. So what rule could we write to go all the way from our pre-image to our final image? We're really going to be combining these two rules together. And what we end up with is -x minus 1 and then y minus 3. So I'm pretty sure this rule works, but just to be certain, I want to try it out and see if it actually could be used to map my old coordinates onto my new ones. So let's try it out. I started with 1, 1, 3, 5, and 5, 1. So I want to take the opposite of each x coordinate and then subtract 1. And I just want to subtract 3 from each y coordinate. And it looks good. It looks like my rule works. So that's one way I can be sure that I came up with the right rule. Can you figure out what type of transformation these rules represent?
You may be able to tell just by looking, because maybe you're familiar with the patterns of reflections and rotations and translations and how they affect coordinates. I'm going to figure it out using my coordinate grid. First, start out by drawing a shape. I'm going to draw a right triangle. I find them easy to work with. So let me write down the coordinates of the points of my triangle XYZ here. And then I'm going to see how those would change after this rule is applied. So first, I'm going to write down my original y coordinates because I notice my x's and y's are changing position. So the y's are going to come first, and I'm going to subtract 3 from each of those. Next up is the x's, and I want to subtract 1 from each of those. So here's my image. What kind of transformations could I have used to map my pre-image onto my image? Well, one way to do it is to first reflect across y equals x. That would give me this little green triangle right here. Now to map that onto my final image, I just need to go 1 down and 3 to the left. So that's a set of transformations that would allow me to map that pre-image onto that image. So that is represented by the rule right there. Why don't you try the next one? So pause the video, try it out, and then hit play when you're ready to see what it looks like. I know you got this.
So I made an example pre-image and then I applied this rule to create its image. You could have used any shape you wanted. I just made my own triangle and then applied the rule to see what would happen. So how can I get from my pre-image, which is black, to my image, which is blue? Well, I started out by rotating 90 degrees and then 90 degrees more. So for a 180-degree rotation, I went clockwise, but counterclockwise would have been the same thing. And then the next thing I needed to do was translate up 5. So this rule matches this sequence of transformations.